In B, we have just found an asymptotic expression for the ruin probability in the case where we have two independent lines of business and one of them is light-tailed while the other is heavy-tailed Pareto. In B, we just had pure insurance, no reinsurance. Now in C, we are asked, how would the ruin estimate change if we buy proportional reinsurance? Now there is something about the word reinsured that kind of makes us guess that probably the probability of ruin will decrease. However, let's just try to calculate a ruin estimate to be sure. So in C, we are told that we buy proportional reinsurance for which we pay the premium CR equal to 1/2. So this is the reinsurance premium. And they also give us the self-insurance function, Sx. So S of x is equal to x halves for claim size x. And this just means that the part of the claim that is paid by the insurance company itself is the claim size divided by 2. And that also means that half of the claim is then covered by the reinsurance company. So i.e., we cover half of the claim, while the reinsurance company covers the other half. Well, since we've gotten this written down, then it's actually quite easy to write down an expression for the total capital in our case, which is then different from the total capital that we have up here. Because what we now have is, well, the initial capital is still U. However, the premium is now just 1/2, right? Because we charge a premium rate of 1, but we have to pay a premium rate of 1/2. So the total premium rate is 1/2. On the other hand, the claim size is also halved because half of the claim size is reimbursed by the reinsurance company. So our total claim size would then be yi divided by 2, summed for I going from 1 up to the number of claims in tilde. So what we just basically have to do now is recalculate our ruin estimate. Now the only thing that's happened to the claim sizes is that the claim sizes are now half as big as they used to be. So it's just a scaling of the claim sizes. Hence, these claim sizes here are just as heavy-tailed as they were before. And therefore, we have, since y tilde I have are heavy-tailed, we will use theorem 215. And from theorem 215, we have that an asymptotic expression for the ruin probability would be, well, what is it? It's the claim arrival rate, which is still 1/2, divided by the premium rate, which is now 1/2 instead of what was previously 1. And we have to subtract the claim arrival rate multiplied by the expectation of the claim size, which is the mean value of y1 tilde divided by 2. And then we have to multiply by the integral from u to infinity of the probability that y1 tilde, so what we want is the tail probability of y1 tilde halves. So the probability that this is greater than x with respect to x. Now let's just take things one at a time. What is the mean of y tilde divided by 2? In our previous calculation, we concluded that y tilde had the mean value of 1. So that was what we found out in B. I think y tilde 1 has the mean value of 1. So y tilde halves has the mean value of 1/2. So what you have here is 1/2 divided by 1/4. Which is quite clearly 2. And apart from that, what we see here is that we're actually just considering the probability of y1 tilde being greater than 2x. Just multiply the 2 onto this other side. This event and this event are actually just equivalent events. And now we use the same trick as we used in B, where we note that the tail probability of this claim size is mainly dominated by the Pareto part of the mixture distribution. So you have this tail probability here, which is a mixture of an exponential tail and a polynomial tail. And as soon as we evaluate this tail probability in sufficiently large values, well, then the integral of this first part will just die compared to this part. So it will be dominated by this part, and we can write 1/2 multiplied by 3 divided by 3 plus, and now instead of x, our argument is 2x to the 4th dx. And if we just do a quick calculation of this, then what we should get is, well, the 2 and the 1/2, they actually cancel. The 2 and the 1/2, they cancel, right? However, when we try to find the antiderivative of the thing that's inside here, what you actually get is you have a 1/2 from this part that comes out. So we then take the, what do we have here? You have 1 divided by 3 again, also with a minus up in the front, and 1 divided by 3 plus 2x to the 3rd. And you take that from u to infinity. And what we get is then 27 halves multiplied by, well, when we plug infinity into this expression, you just get 0. And then you have minus this term evaluated in u, which is 1 divided by 3 plus 2u to the 3rd. And the thing that happens here now is, well, the 3 here is just a translation of something that's very large. So this is asymptotically equivalent to 27 halves multiplied by 1 over 2u to the 3rd. And this is then equal to 27 divided by 16 multiplied by u to the minus 3rd. And what we now see is that in the case of proportional reinsurance, the ruin probability has decreased by a factor 8. So by a factor 2 to the third. So by decreasing our premiums by a factor 2 and also decreasing our claims by a factor 2, we have reduced the probability of ruin by a factor 2 to the third. And now Jeffrey or Schmidley asks us, would it be preferable to buy reinsurance? And there the answer is, so is it preferable to buy reinsurance? And I would say the answer is, it depends. Do you like risk? Or do you not like risk? Because if you like risk, then it probably doesn't mean that much for you to reduce the ruin probability, because on the upside, you get to earn a higher premium as well. Because here, when you outsource half of your business, well, then potentially your potential highest income is lower compared to if you just take all of the risk yourself. So whether it's preferable to buy reinsurance or not, well, that kind of depends on whether or not you like risk, right? So in order to talk about this in a more quantitative way, it would require some knowledge in utility theory, which unfortunately is not a part of this course's curriculum. But in order to address whether it's preferable to buy reinsurance, we will need to talk utility theory.